Alright guys, we're going to have our exam Unit 5B tomorrow, so this is going to be just a few problems that I want to go over to keep fresh in your mind so that you can do well tomorrow. Alright guys, as I mentioned on Thursday, 4 of your problems on your test are going to be just basic integrals, and each one of them are going to be worth a point and a half. So out of 18 points, that's going to be 6 points on your test. And so I'm going to run through a couple of examples here just to keep these fresh in your mind. I'm going to do actually 2 examples like this where you have a fraction and you have something on the bottom and you need to divide that into both of the terms that are on the top. Alright, so I'm going to separate this as the integral 1 to 4, and matter of fact, I'm going to do it a little different. I'm going to move the x to the 1/2 up to the top, and so it's pretty much the same thing. I'm going to move it up there, and that's going to make it x to the negative 1/2, and then I'm going to distribute that in, and we're going to get 4x to the negative 1/2 plus 6x to the positive 1/2, because there is an exponent of 1 right there, and when you multiply like bases you add the exponents, and that's going to give you a 1/2 there. And if we keep going here, we have to do the power rule, so we're going to add 1 to the power there, we're going to add 1 to the power there, and when we add 1 here you get a positive 1/2 for that exponent. But when you divide by 1/2, that's the same as multiplying by 2. And so this is going to end up being the integral from 4 to 1 with a straight line of 8x to the 1/2. And then here, 1 plus 1/2 is 3/2, and so that's you're going to be dividing by 3/2, which is the same as multiplying by 2/3. And so maybe over here we'll do 6 times 2/3, and that gives us 12 over 3, which is 4. Alright, so we'll erase that, and we'll say that that is going to end up being 4. So plus 4x to the 3/2 power. And at this point you're going to plug in your upper and your lower limit. Alright, so if you plug in 4, you're going to get 8 times the square root of 4, really, plus 4 times 4 to the 3/2 power. And I'm going to write the 3/2 power as 1/2 to the 3rd, because you are still multiplying exponents when you have an exponent to an exponent, so that gives me 3/2. So I'm going to end up getting 2 times 8, which is 16. And then here I'm going to take the square root of 4, which is 2, cube it, which is 8, times 4, which is 32. And that's going to be 48. Okay, now don't forget, that's just the upper limit plugged in. Now we've got to do the lower limit. Alright, now the nice thing about the lower limit is that it's 1. And anytime you plug 1 into a function, you just end up getting the coefficients, because 1 to any power is just 1. So that ends up being 12. So 48 minus 12 is 36. And that would be the answer to that particular problem. These are problems that you need to be able to do quickly. Don't rush, but you know you only have 50 minutes, so you need to be able to do these types of problems relatively quickly. So practice these. Okay, here's a real simple integration problem if you remember your table of integrals. If not, you may stare at it for a while and struggle to figure out how to do it. We remember that the derivative of the secant is secant tangent. So the integral of the secant tangent must be secant. So this is going to be the secant pi over 6 to pi over 4 secant of x. And so now all we have to do is really just plug in our upper and our lower limit. So this is going to end up being secant of pi over 4 minus the secant of pi over 6. And we know that secant is the flip of the cosine. So if cosine is adjacent over hypotenuse, then the secant is the hypotenuse over the adjacent. And so the way I do these is I use the 45, 45, 90 and the 30, 60, 90 triangles. So if we have a 45, 45, 90 triangle, the sides are 1, 1, root 2. And if we're looking at, let's just say that angle there, 45, then it's going to be the hypotenuse, which is root 2, over the adjacent. So this is going to end up giving us root 2. And then if we take a look at the 30, 60, 90 triangle, so we'll call that 30, and we'll call that 60, and this is 90. Across from 30 is 1, across from 60 is root 3, and across from 90 is 2. So once again, pi over 6 is 30 degrees, and so we are looking at this angle right there. And so if we say the hypotenuse over the adjacent, well, that's going to be 2 over root 3. 2 over root 3. And we can leave it like that, or we can get the root 3 off of the bottom by multiplying by root 3 top and bottom. And so that's going to give us minus 2 root 3 over 3. And that's going to be the answer to that integral. All right, another focus of the exam tomorrow is going to be the Fundamental Theorem of Calculus Part 2. I cannot stress how important this is. There's going to be a few problems that are just basic, where you need to be able to find the derivative of an integral. And so we've been over this several times. And you really need to understand the chain rule version of this. And so basically the idea here is, if you have a number, and let's just say that's 1, and you're going to an upper limit of sine of x, well, this one has a constant, and so you're not going to have a second part to the chain rule, but you do need to plug that sine of x into the function and then multiply by the derivative. So number 6 is pretty simple. It's just going to end up being the square root of 1 plus sine cubed of x times the derivative of sine, which is cosine of x. All right? So number 7 is going to be similar, except this time you have a lower limit of the sine of x and an upper limit of x cubed. And we actually don't have an actual function to plug into this time, so we're going to have to leave it generic and leave it in terms of f of x. All right, so if we do this one, it's going to be f of x cubed, because you're plugging in the upper limit, times the derivative of x cubed, which is 3x squared, so I'm going to put that in front, minus, you're plugging in the lower limit now, so that's going to be f of sine of x. And then you have to multiply by the derivative of sine, which is cosine of x. So I'm going to leave that one in front there. All right. And last one, number 8. Now we have a similar situation, except now we're plugging in to the function e to the t squared. So this is going to be, once again, the idea, don't forget, is that the derivative, okay, the derivative and the integral are going to undo one another. So here you end up having e to the t squared. So t you're going to replace with x cubed. So this is going to be x cubed quantity squared. And then you have to multiply by the derivative of x cubed, because that's the upper limit. Once again, when you have something that is not just an x, as your upper or your lower limit, you have to apply the chain rule. So that's going to be 3x squared. All right, minus, and now we're plugging in our lower limit, so that's going to be e to the sine of x squared. So we write that as sine squared x. And then we take the derivative of the lower limit, sine of x, which is cosine of x. And we'll clean this up a little bit. X cubed squared, multiply your exponents, so that's going to give you a final answer of 3x squared e to the sixth minus, oops, excuse me, not e to the sixth, e to the x to the sixth minus cosine of x times e to the sine squared x. And that is the answer to this problem. All right, this is a pretty simple one. This is really the application of the fundamental theorem of calculus part 1. And so the idea here, if you look at this, you have the integral of f prime of x is equal to 15. And we know that f of negative 7 equals 4. What does f of 9 equal? So if we have the integral of from negative 7 to 9 of f prime of x dx. We know from the fundamental theorem of calculus part 1 that anytime you have an integral and you're integrating a derivative, that gets you back to the original function, evaluate it at the upper and limit minus the lower limit. So that's going to equal f of 9 minus f of negative 7. All right. Now, they tell you up here that this integral from negative 7 to f prime of x equals 15. So this is going to equal 15. And they want to know what f of 9 is. So they give you that f of negative 7 is 4. And so we can replace that with 4. So we have f of 9 minus 4 equals 15. And so f of 9 is going to end up being 19. And that's the answer to this problem. All right, here's another application of the fundamental theorem of calculus part 1. All right, so we have this graph here, and it's comprised of lines, and so when you see that, you automatically know that you're going to be having to do some sort of area to end up expressing the integral. All right, and so they giving us the h prime of x is given below, and they also give us h of negative 2 is equal to 6, and what does h of 3 equal? So once again, the way you want to set this up is you want to say, okay, I want to integrate this function from negative 2 to 3 of h prime of x. And let's just be accurate and put dx. Now, fundamental theorem of calculus part 1 says that that is going to equal, because you're integrating a derivative, that gets you back to the original function, h of 3 minus h of negative 2. Okay? And h of negative 2, they give us to be 6. All right? And so we can actually replace this with 6. So let me just rewrite it this way. It's going to be h of 3 minus 6. And so if we want to get the integral of h prime of x from negative 2 to 3, that means we need to find the area between negative 2 and 3. All right? So let's go ahead and do that, but also let's also work smart. All right? We see that this little area right there and that area right there are going to be the exact same, and one is above and one is below. So they're going to cancel each other out. So we really don't need to compute those areas at all. So we really only need to compute this area here. All right, and so I'm going to go from -2, all right, to 0 first. Actually, let me go back here. We don't need that. We need this. All right. So I'm going to go from -2 to 0 first. And that looks like a trapezoid, but I'm going to break it up as a rectangle and a triangle. All right. So, matter of fact, let's just do this. Let's get it all in one. I'm going to go from -2 to 1, and that way we'll just have to do one rectangle, which I'm highlighting right now, and then a triangle. Okay, so the rectangle area is going to be base times height, so that's going to be 3 times 1, that's going to be 3. And then the triangle is going to be, well, remember the triangle formula, the base times height divided by 2. Well, the base is 3. The height of this triangle looks like it's 2 divided by 2. So that's also going to be 3. All right, and so you add 6 to both sides, and you end up getting h of 3 equals 12. And that is the solution to this one. All right, we've got one of these functions that is defined as an integral. So h of x is equal to 9 plus the integral from 4 to x f of t dt. And in part A, we are asked to find h of 4, h prime of 4, and h double prime of 4. All right, so h of 4 is simply going to be 9 plus the integral from 4 to 4 of f of t dt. And you're looking at the graph and you're saying, wow, I don't know how to find the area under the curve because it's not lines, it's not semicircles. But hey, it doesn't matter here because anytime you are integrating from a number to the same number, that area is 0, and that ends up being 9. So h of 4 simply equals 9. Now, be careful, be careful, be careful, because we could switch this problem around, and we'll tell you what, I'll come back to that later. Let's just go ahead and do h prime of 4 and h double prime, and then I'll come back and say what I was going to say. All right, h prime of 4 is going to be, all right, h prime of x. You have to take the derivative of 9, all right, which happens to be 0. So 0 plus the derivative of f of t from 4 to x, that's the fundamental theorem of calculus part 2, so that's just going to be f of x. Now, this is what I was going to say. Please be careful, because if we give you something other than 9, let's suppose, for sake of argument, that we give you something like h of x equals e to the x plus the integral of 4 to x f of t dt. When you take the derivative h prime of x, well, tell you what, let's just go through that whole problem again. Well, if we asked you to find h of 4, then you would actually need to plug 4, and it'd be e to the 4th plus, and that would be 0. All right, but if we said h prime of x, then notice that the e to the x is not a constant. That's not going to go away. So you would need to take the derivative of that, and that would end up just simply being e to the x plus f of x, because the derivative of an integral is from a constant to a variable is just that function with the x plugged in. And so now to find various values of h prime, let's say you wanted h prime of 4, well, now you would be e to the 4th plus f of 4. And so you'd have to go in and you'd say, okay, well, f of 4, that looks like that would be -1 right there. And so the final answer would be e to the 4th minus 1. All right, so be careful and be aware of those types of problems there. All right, so let's go back to our problem. We're looking for h prime of 4, which is going to be 0 plus f of 4. And f of 4 is, once again, -1. So that's just going to be -1. All right, so h double prime of x is simply going to be f prime of x. All right, and so the derivative of f of x is f prime. So that's the slope at 4. So h double prime of 4 is really f prime of 4, or the slope of f of x at, that's not very good, we'll just spell it out, at x equals 4. And it tells you in the problem that there is a horizontal tangent line at x equals 4, so that means the slope of that graph is 0. So the answer for h double prime of 4 would be 0. All right, part B. On what intervals is h increasing? Well, h, let's just write it out. H of x increases when h prime of x is greater than 0. And we learned from the last problem that h prime of x is equal to f of x. So essentially, we're asking the question, where is f of x greater than 0 or above the x-axis? And it looks like it is above the x-axis here and here. So our final answer would be in interval notation, -2 to 2 in union with 6 to 10. That would be where it is increasing. All right, part C. On what intervals is h concave downward? Well, if it is concave downward, h double prime of x would have to be less than 0. So h prime of x, we said, was f of x. So h double prime of x is f prime of x, or the slope of f of x. Okay, so the question is, where is the slope of f of x less than 0? Well, you can see that it's going to be for all of this part of the graph right there, because the slope, if you draw tangent lines, there's going to be negative slope there. So your final answer there is going to be from -2 to 4. All right, a few more parts to this problem because I want to make sure you understand everything really well for the exam. Part D, find the trapezoidal sum to approximate the integral of -2 to 10 using 6 subintervals of length 2. Now we like these problems because if they give us an equal length of each subinterval, we can just use the formula for the trapezoidal sum. Let's review that. That would be the height over 2, don't forget divide by 2, of f of 0 plus 2 times f of 1 plus 2 times f of 2 plus ... and then f of whatever the last number is in there. All right, so for our problem, the height is really the thickness of each trapezoid. In this case, it's going to be 2. So it's going to be 2 over 2, which is 1. And then we're going to use our leftmost point, so that's going to be f of -2, plus 2 f of 0 plus 2 f of 2 plus 2 f of 4 plus 2 f of 6 plus 2 f of 8 plus only 1 f of 10. And we got to plug all those values in. So 2 over 2, I'm just going to give that and call that 1. Alright, so f of negative 2 looks like it's 2, plus 2 times f of 0. F of 0 is 1 times 2 is 2. And then f of 2 is 0 times 2, that's going to be 0. F of 4 is going to be negative 1 times 2 is negative 2. And then f of 6 is 0 times 2, that's going to be 0 again. F of 8 is going to be 1, so that's times 2. And then f of 10 is going to be 2, and we only need one of those, so you don't double the right and left point. So it looks like the negative 2 and positive 2 cancel there. And so we end up getting 1, 2, 3, 4, 5, 6 as our answer. And 6, let's just keep in mind what that is. That is the approximation, okay, approximation of the integral of negative 2 to 10 of f of x. Okay, now let's expand this problem here, and let's say we wanted to find the average value. Okay, of f of x. Well, the average value, remember, is the integral over the interval. So the integral we have approximated to be 6 divided by the interval, which would be 10 minus a negative 2, which is 12. So 6 over 12 reduces to 1/2, and that would be our final answer for the average value. And you can see that that looks to be about right. At 1/2 is that line right there, so that looks to be about the average value of that function. Alright, last part of the review would be, it's not on this particular problem, but let's say we wanted you to find the tangent line. Let's say we wanted to find the tangent line to the curve at h of 4. So we say, maybe we'll say it like this. What is the equation for the tangent line to h at x equals 4? Alright, so anytime you're trying to do a tangent line, you need h of 4 and h prime of 4, which we got in letter A. Alright, so h of 4, if you remember, that was simply 9. So we have the ordered pair 4, 9. And h prime of 4 was simply, if you remember, h prime of 4 was equal to f of 4, which was negative 1. So we can use our point slope form, so it's going to be y minus 9 is equal to the slope negative 1 times x minus 4. And we can leave it in point slope form, and that should be good enough. So guys, email me with any questions tonight. I'll be around. I'll also be in my room tomorrow at 7 o'clock in the morning if you have any questions. All right. Study hard. You'll do great.